Hello all. In this lecture we will discuss about compaction. Okay. In last videos we have discussed about the fragmentation topic. Okay. In fragmentation topic what happens? There are two types of issues. The first one is internal fragmentation and the second one is external fragmentation. Okay. So both are the issues. In both cases memory is getting wasted. In internal fragmentation, this type of fragmentation is seen in fixed variable allocation, whereas external fragmentation issue is seen in variable allocation. Okay, so this in those two issues, the external fragmentation issue is somewhat resolved by using this compaction. Okay, so what is compaction actually? Compaction is a process in which the free space is collected in a large memory chunk to make some space available for the processes. Okay, so here if external fragmentation is seen, so all the leftover memory space is collected and made it as a space available for the new process. We will see it with an example. Okay, so this is the example. Here what happened? Let us think that here this is there. Okay, this is of some 100 KB slot. Okay, block, some memory slot. Let us think this is the 100 KB memory slot. In this 100 KB memory slot, I have one process which requires only 70 KB space. So here 30 KB is wasted because it is of 100 KB memory slot, and here my process requires only 70 KB. So remaining 30 KB is wasted here. This is the problem of fragmentation. Okay, so this is an external fragmentation. Okay, why it is called as external fragmentation means here the leftover space. Okay, here the space is left over here. Okay, so here here in all these there is a problem of external fragmentation. So here also there is a problem. Space is wasted. Here also memory is wasted. Here also memory is wasted. So what happens? What is the use of compaction means? All the wasted memory slot. Okay, these many memory slots are getting wasted. So all these memory slots are joined together and made it as a space for the new processes. Okay, so if this much of space is there, if my process needs some 20 KB, this is of only 10 KB, so my process will not fit into this, so it is getting wasted here. So that is why these all wasted memory is joined and made it as a space available for the new process. Okay, this is the use of compaction. Okay, well, now we will see the problem with the compaction. So though it has some advantage, it also have a problem. It also have a disadvantage. What is that? Here the efficiency of the system is decreased in the case of compaction due to the fact that all the free spaces will be transferred from several places to a single space. Means now operating system have to search everywhere. From the starting to ending, it has to search for the wasted memory. So for the searching itself, the efficiency of system is decreasing because it is having some work. Okay, so not only executing the processes, now it is also some other work. What is that other work? It has to check for the wasted memory. So for on the both cases, it has to keep its efficiency. So here efficiency of the system is decreasing because it is working on the both problems. I mean both it is executing some two processes. First one is executing the processes, second one is searching for the wasted memory. So the efficiency of the system is not definitely decrease. This is one of the problem with the compaction. And the second one is huge amount of time is invested for this procedure and the CPU will remain idle for all this time. See, so what is the work of CPU? CPU work is to execute the processes. Okay, so when CPU is allocated to the process, then only CPU will be busy. When CPU is not allocated with any process, then CPU will sit idle. Here, why will CPU will sit idle means because operating system is searching for the available spaces, wasted memory. So in that case, when operating system is searching for the available case, nothing is there to allot processes to the CPU. So CPU will sit idle for all this time. So this is also one of the problem, because CPU utilization should be more and more at every time. So here when CPU is sitting idle means CPU utilization is less. That is the problem. Despite of the fact that the compaction avoid external fragmentation, it makes a system insufficient, as it is solving a problem of external fragmentation, but it is also making the system inefficient because of these two problems. This is the problem with compaction. But the only advantage of using this compaction is it is avoiding external fragmentation. Okay, thank you.